Good morning to all. So, in this session, I'll just brief regarding what is NoSQL. NoSQL stands for not only SQL, a class of non-relational databases. So, whatever we have understood, ER diagrams, conversion of ER diagram to relational schema, so representation of the entire requirement in the form of tables, it is nothing but relational databases. So NoSQL is a class of non-relational databases, and NoSQL has become more relevant in nowadays because of unstructured data. Earlier, we just concentrated more on structured data. Now we are concentrating on unstructured data. What is the usage of NoSQL? The usage of NoSQL is it is used for high scalability, schema flexibility. So high scalability means you can make changes very easily. Schemas can also be changed flexibly, and it can also be used for managing big data contents. So these are three relevant applications of OSQL. So as I mentioned, the structured databases are something like you have specific rows and columns. So that becomes a structured contents. That becomes a structured content. So if it is in the form of table, if the requirement is shown in the form of table, we call it as relational databases. But like for example, let us take an image, and from an image, you can have lot of contents being retrieved. So you can say that a specific design object has some contents. Okay, let us assume that oval shaped one. Okay, you can list out few objects within that image. Rectangular, okay, you can retrieve some objects. So indirectly, it's something like for every instance, you have some other related data. Or let us assume that, okay, you have a content that is retrieved, okay, by the, okay, uh, so there might be a chance that okay, I get into a retail shop. There are a lot of items. If you are representing it in a row oriented, something like if you are representing something like this, then fine for a customer X, you'll get nearly around 100 items. But among them, you'll just be buying only two. So rest of them will have null values. Rest of them will have null values. So to overcome that, I'll just use, okay, fine, transaction ID is X, but I know that he has chosen only item one. Okay, so item one is chosen and item two is chosen. So I'll try to save it in this particular fashion. So if I save it like this, then it becomes a non-relational database. And then now it becomes a non-relational database. I hope the initial content is pretty clear. So NoSQL stands for not only SQL. Uh, it is used for three important things. One is okay scalability, so you can add a number of contents and make it very simple. Flexible because changes of the design can be done okay in a better fashion. And handling it's basically used for handling semi-structured and unstructured. As I indicated, image, audio, some okay contents are also unstructured. Okay, unstructured. So for all of them, it is non-relational databases that we will be using. So let us try to understand what are the different types of NoSQL databases. So we have a key value store concept. We have a document stores, column family stores. And the last one is graph databases. So these are the four different NoSQL databases that exist in the market. Let us understand the first one, key value store. So you can just observe in this particular diagram, there's a key and there's a value. In the value, you can also observe that each one of them contents can be different. So the first one has the name, okay, it has them, okay, well, let us assume that it has the first name, middle name, age is there, some value is there. But in the second one, in the second key, you can observe there's some text content. So there's no specific format that we follow. we try to have multiple values separated by a comma. So indirectly, we are demolishing the normalization concept that we studied. So in key value store, okay, data is stored as a collection of key value pairs. So there's some key for identification of the value, but value is not fixed. Value can be anything. Okay, value can be a document. Value can be okay. Let me say phone number. So there's no fixed structure for it. But there is a means for retrieving all these data in a proper manner. The key is unique because okay, I need to retrieve the values. So okay, that's the reason why key is unique. The value can be anything. Okay, value can be anything. Value can be a document. It can be multiple values. There's no restriction. Um, so the advantage is fast read and write because okay, you have a key and there's an appropriate document which is symbolic to whatever that we have right now. So it is okay faster and predominantly key value stores are used in most of the applications. Just to show you an example in Redis. So how do you set it? You say 101 is the user. You have said Alice, Bangalore 256. So you have three values there. 101 has three values. Alice, Bangalore is the place and some number 256. So if you take 102, you have Bharat, Mysore. And now you have 256, but you have one more value. So a mobile number is also added. So you can just observe there is no structure. Okay, each one of them is using a different format, but you know the ordering. Okay, there's some specific order. So that is the advantage of using okay key value pair, key value pair. So how do I retrieve it back? I can just say get user okay 101. Okay, when if I say something like this, it gives me the entire data, or it can be very specific. Also, specific fields can also be retrieved. For that, additional okay representation should also be used. Right now, we'll not get into the additional representation. So let us come to the document-oriented databases. So as I indicate, as it mentioned, document-oriented databases. So stores the data as documents. Okay, so it saves everything in the form of documents. Each document is self-describing and can have a different structure. So each one of them is self-describing and can have different structures. More flexible, quite naturally. For hierarchical data representation, I feel document-oriented store will play an important role. So the best example is a MongoDB. You can just observe. This is ID 101 is being indicated. Name is Alice. Email is this. Skills. Okay. So indirectly, I've read the resume and we have formed it in a JSON format, which MongoDB can actually read it. But this is the actual representation of JSON, and this is supported in MongoDB. So this is the content. This is a very simple document. So entire document is being represented now in the curly braces, wherein okay, ID is there, name is there, email is there, skills is there. So you may try to represent a resume in a different format, then the additional fields will automatically come. So what are the different queries? I can just say DB user find the name Alice. So it gives me the entire details of it. So very simple representation of a MongoDB. So let us come to the column family stores. In column family stores, store data is stored in a column rather than rows. So we don't use a row-wise representation. We go for a column-wise representation. So that's the biggest change over here. So in relational databases, it is row-wise representation. No, I'm not saying I'll convert it, but how do I save it is in the form of columns. Um, so we call it as column families, a group related. Okay, so together two for retrieval. This is actually required when okay when the table is too huge. You have around 2000 fields and okay you are reading it in a column representation always, then fine, column family stores will actually be an answer for it. So like for example, this is the example of a relational database. So you have row number 1, 2, 3, 4. Of course, S number becomes an ID for our representation. Now, how do I convert it into columns? Okay, I'm just taking a very simple example with three okay, columns, but practically you should assume that there are around n number of columns. Or if there are n number of columns, then fine. It becomes read heavy because I will be reading everything. So to overcome this disadvantage, we split it into columns. So I'll split it in the first column. This becomes a column-oriented representation. You can just observe. I've just taken all the names separately. I've taken all the branches separately. So this is the representation. This is what, okay, uh, relational databases, which is a row-oriented representation. So how am I representing? I'm taking every column, representing it separately. So that is the representation in case of column-oriented representation or column-oriented databases. Okay. So the last one that we have is the graph-oriented one. The graph-oriented became very, okay, let me say predominantly useful because it actually represents the database in terms of graphs. And but the disadvantage is you cannot have huge memory for every node. Every node you have very simple contents. It is desired to store, okay, data in the form of nodes, entities, and it just will, okay, actually represent in the form of relationships. Uh, so if there are a lot of interconnected data, something like, okay, finding out friend of friend, okay, or I have a specific skill, I want to know, okay, who are the persons who are related to it, then the graph databases will actually play an important role. Okay, the best example is the social networks, identifying frauds, recommendations. Okay, all of them use graph databases. This is one such example. Okay, we say person A name is Alice, person B is Bob. We actually say, okay, we create a friend. Okay, we say A is friend of B. And once we write a query, okay, try to match, okay, friends of A, then fine, it retrieves B. But you should imagine that all of them is in the form of, okay, circles like this. Okay, so you have information present in the form of nodes, like for example Alice, you have a Bob. So there's a different, okay, just to understand, okay, let us assume that I use a single line to represent friendship. Okay, I use double lines to represent hobbies. So there might be chance that, okay, the same information can also be there. Like for example, this is a single line. It means that A and B are friends. Okay, A and C is, okay, they have common hobbies. Okay, they have a common hobby. Okay, but you can have both these edges. Okay, both the form of edges over here, from both the ends. So it's something like you represent everything in the form of graph. Okay, you represent everything in the form of graph. So the question that might be asked is, what is NoSQL? So explanation of NoSQL and different types of NoSQL databases. This is the answer that you are supposed to write.